Good day, students. So, this is the biomolecules course, and in this course, you will tackle the four major biomolecules in four chapters. So, those biomolecules are carbohydrates, the proteins, the lipids, and the nucleic acids. So, in our first chapter, we will tackle the carbohydrates. So, carbohydrates, we all know, are the sugars, and sugars occur in every living organism. The sugar and starch in food and the cellulose in wood, paper, and cotton are nearly pure carbohydrates. We also have modified carbohydrates that form part of our coating around our living cells, and other carbohydrates are part of the nucleic acids that carry our genetic information, and others are used as medicines. So carbohydrates has a formula of C6H12O6. So before, they historically thought that the term carbohydrates was from the formula itself. Parang ang carbohydrates ay ang hydrate ng carbon. Pero eventually, na-abandon yung ganitong paniniwala, and as of today, the accepted meaning of carbohydrates is that carbohydrates refer to the broad class of polyhydroxylated aldehydes and ketones, commonly called sugars. Polyhydroxylated meaning meron tayong mga hydroxyl groups. Ito yung may mga OH groups. And also, kung naaalala nyo yung aldehydes and ketones, so ang aldehydes has a double bond on the first carbon, while ang ketone has double bond on its second carbon. So, the most familiar example of sugar is the glucose. So, paano ba nagagawa yung carbohydrates? So, carbohydrates are synthesized by green plants during photosynthesis. So, the glucose produced in photosynthesis are stored in plants in the form of either cellulose or starch. So, tayong mga tao and most other mammals, we can only digest starch, and we have a source of readily available energy in the form of carbohydrates. Kaya, ang carbohydrates act as the chemical intermediaries by which solar energy is stored and used to support life. So we have classifications of carbohydrates, and we have two classifications of carbohydrates. So first, we have the simple carbohydrates. Simple carbohydrates are basically the monosaccharides, and the complex carbohydrates are sugars that are made of two or more simple sugars linked together by acetal bonds. So example of complex carbohydrates are sucrose, cellulose, and etc. And also, simple carbohydrates cannot be converted into smaller sugars by hydrolysis, since isang unit lang ng sugar ang meron sila, unlike sa complex carbohydrates. Simple carbohydrates can be further divided into aldose or aldehyde or ketone. So aldose or ketose. So ang aldehyde, 'di ba meron silang CHO functional group. Wait, we have this. Yan. So this one is the aldehyde group. And this one is the ketone group. As you can see on the ketone group, yung second carbon, doon nag-double bond yung ating oxygen. Unlike dito, sa aldehyde, first carbon ang nag-double bond sa oxygen. So, meron ng way tayo para mag-name ng monosaccharides, and we name it by identifying if they are an aldose or a ketose. And then, ang huli niya, parang ang suffix niya is OSE, na ang ibig sabihin ay carbose. And then we will also count the number of carbon atoms in the monosaccharide. Okay, pwede siyang pentose, ibig sabihin 5 carbons na aldehyde siya. And pentose, 5 carbons na sugar pala. Sorry. So, let's have first this one. Okay. Let's have first this one. So, ilan ang carbon niya? So, 1, 2, 3, 4, 5, 6. So, that's hexose. So, that's hexose. Ano bang group ang meron siya? Aldehyde. So, that makes it an aldohexose. So, yeah. On this one naman, we have fructose. So, ang name niya as a monosaccharide is 1, 2, 3, 4, 5, 6. So, that's hexose. And then, siya ay isang ketose. So, that's ketohexose. So, in this one naman, sa ribose, we have 1, 2, 3, 4, 5. So, that's pentose and siya ay isang aldose. So, siya ay aldopentose. On this one, we have pseudoheptulose. So, the name ay hep. Ibig sabihin, meron siyang 7 carbons. So, that's heptose. And siya ay isang ketone. So, ketoheptose. Yan. So, that's how you name the monosaccharides. And on your worksheet number 1, you classify each of the following monosaccharides. So, in-name nyo sila kung paano natin in-name yung previous sugars. So, ayan. That's your worksheet number 1. Okay. So, next. Okay. The last kind of naming carbohydrates is the stereochemistry. Yung stereochemistry deals with the spatial arrangement of atoms and groups in molecules. Because carbohydrates usually have numerous chirality centers, it was recognized long ago that a quick method for representing their stereochemistry was needed. Let me clear that. Yeah. Okay. In 1891, the German chemist Emil Fischer suggested a method based on the projection of a tetrahedral carbon atom onto a flat surface. Diba, nung organic molecules natin, ang sabi daw na ang carbons ay ang ating mga molecules ay exist in a tetrahedral model. Yan. So, ang gusto ni Emil Fischer is to simplify yung model na yon for people to understand easily. So, ang gusto niya is to press flat the tetrahedral carbon atom. So, these Fischer projections were soon adopted and are now a common means of representing stereochemistry at chirality centers, particularly in carbohydrate chemistry. So, itong tetrahedral carbon is represented in a Fischer projection by 2 cross lines. So, ito yung 2 cross lines. Ayan. So, yung mga horizontal lines na parang paalis ng papel, ayan, yung paakyat. Ito yung mga nasa horizontal. And those naman na vertical lines, ito, yung nasa vertical lines, this one, represents the bonds going into the page, papunta daw sa page. Ayan. So, ito yung horizontal at ito yung vertical. So, yan ang Fisher projection. So, let's have an example. So, let's have this glyceraldehyde. So, let's determine its Fisher projection and its tetrahedral carbon atom model. So, lagi natin tatandaan, longer line means away from the viewer. So, pag away sa atin, papuntang right. Shorter ones towards the viewer. So, the line is papuntang left. Okay. So, let's have this one. Yan, this one. So, and the first carbon, so lahat ng black ay carbon, lahat ng red ay oxygen, at lahat ng puti na balls ay hydrogen. So, let's have this one. Ilang carbon? So, 3. 1, 2, 3. So, una muna mag-structural formula muna tayo. So, ang oxygen, mas mahaba yung lines niya kaysa dito sa ating hydrogen, kaya siya ay papuntang left. Yan. Tapos, ito naman din, ganun din, mas mahaba yung oxygen, kaya nandito siya. Tsaka hydrogen. Ayan. On this one, baka malito kayo na dapat ito ay nasa baba, pero hindi. Kasi, ang ating oxygen has longer line kaysa dito sa dalawa. So, siya pa rin ay nasa right. And dito na yung dalawang H. Ayan. So, ito yung structural formula. Ayan. So, from this structural formula, gagawin na natin siyang Fisher projection. So, ilang chirality center? Isa lang. Isa lang naman ang center na carbon dito sa ating glyceraldehyde. So, ito ang chirality center na tinatawag. And, simplify lang natin ito, 2COH, and this one, 2CH2OH. And, isusulat lang natin yung places ng H at saka OH. So, ito ang Fisher projection ng ating glyceraldehyde. Ayan. Tapos pala, ang tetrahedral carbon atom ay gagawin natin from our Fisher projection model. Okay? So, sabi, di ba, kung sino yung nasa horizontal line, sila yung mga nasa taas, yung parang papalayo ng papel. At kung sino yung nasa vertical line, sila yung parang papasok ng papel. So, sila yung nasa baba. And take note yung naka-shade at saka yung dashed line. Ayan. So, ang tetrahedral carbon atom is only possible with compounds with one chirality center. So, isang chirality center lang. Yung isa lang yung ganyan. So, paano naman yung may maraming chirality center? So, meron lang silang Fisher projection. So, wala silang tetrahedral carbon atom na model. So, on this one, meron siyang 1, 2, 3, 4. 4 chirality centers. Ayan, ganun siya. So, ang ating mga carbohydrates, tulad nito, isang sugar, meron tinatawag na mga stereoisomers. Yung stereoisomers, sila yung mga parang parehas, kabaliktaran nila. Okay? Like this one. Kunyari, ito. Ayan. Pwedeng dito ang OH, pwedeng dito ang H. Ito naman, pwedeng dito ang OH at dito ay H lang. So, ganon. Ganon ang mga stereoisomers. Pag identical, enantiomers ang tawag sa kanila. Pero pag unidentical, mga diastomers. Ayan. And there are motions allowed in Fisher projections. Because a given chiral molecule can be drawn in many ways, it's sometimes necessary to compare two projections to see if they represent the same or different enantiomers. Okay? So, first motion that is allowed in Fisher projection is a Fisher projection can be rotated on the page by 180 degrees but not by 90 degrees or 270 degrees. So let's have example. Let's have this example, the R-glyceraldehyde. So ayan siya. Pag ni-rotate natin, same pa din sila na R-glyceraldehyde. Kasi, yung double bond ay hindi naman na-place dito banda or kahit dito. So, parehas lang, nagbaliktad lang. Unlike, pag ni-rotate natin siya ng 90 degrees, nagbabago pa din. Although, same lang yung, although parang same lang sila ng placement, pero hindi. Kasi dapat, ang ating double bond ay dapat nasa taas lagi. Dapat nandito lagi sa taas ang ating double bond. Okay. So, another motion na allowed sa Fisher projections is pwede nating parang steady yung isang group while the other three rotate in either a clockwise or a counterclockwise direction. So, let's have our glyceraldehyde again as our example. So, itong CHO daw ay isi-steady natin as is lang siya. At itong tatlo ay iikot natin ng counterclockwise. Ayan. So, yun pa din is our glyceraldehyde kasi ang double bond ay nasa taas pa din. So, ganun yun. So, ayan. Ayan. Napansin nyo yung R at saka S, diba? Mayroon tayong R and S configuration. So, ito ang paraan kung paano mag-assign ng R and or S configuration to a Fisher projection. Step 1, rank the 4 substituents from highest ranking group to lowest ranking group. And 2, place the group of lowest ranking, usually H, at the top of the Fisher projection by using one of the allowed motions, yung 180 degrees at saka 90 degrees, pero may steady lang na group. So, this means that the lowest rank group is oriented back away from the viewer as required for assigning configuration. So, step 3 is to determine the direction of rotation of 1, 2, the first, the second, and the third of the remaining 3 groups and assign R or S configuration. Pag ang clockwise, pag ang rotation is clockwise, the configuration is R. If the rotation is counterclockwise, S ang configuration. So, let's have an example. So, first, we have the alanine. Ayan. Sa alanine, so, sabi, dapat daw doon, ang H daw ay lumipat sa taas. So, paano natin i-move yung H? Paano natin siya i-move? Ang H papunta dito sa taas na dapat allowed yung motion na gagawin natin. So, hindi tayo pwedeng mag 180 degrees kasi mapupunta yung H dito. Hindi din naman tayo pwedeng mag 90 degrees kasi mababago na naman yung placement naman nito. Diba? So, hindi pwede yon. So, kailangan daw 90 degrees pero may i-hold tayo na group. So, pwede nating i-hold yung CH3 like on this one. Ayan. So, pwede nating i-hold yung CH3. So, ngayon, pag ni-rotate natin yung ating alanine counterclockwise, so, ang H natin ay nandito na sa taas. And H2 ay napunta dito sa right at saka COOH or CO2H. Yan. So, ngayon, after that, na-place na natin yung H doon sa taas, we will rank the substituents according to their atomic numbers. So, sino ba ang una? nitrogen. Ang sunod, ang carbon. Ayan. Yan, ito, number 2. And sunod ay 3. So, pasaan papunta yung ating direction? It's counterclockwise. So, is it R or S? Diba? So, that's S. Okay? So, ito ay S. Wait lang. So, this is S. Another way naman na i-rotate natin siya, so parang mas malaman natin, 'di ba, yung identity is pwede nating i-hold ang H2N. So pag i-hold natin yung H2N at nag-rotate tayo ng 90 degrees, dito na yung H, ayan. So dito na yung COOH at dito na yung CH3. And we will now rank them according to their atomic numbers from highest priority to lowest priority. So, ang highest priority natin is ang nitrogen. Ayan. So, ang sunod ay this one, 2 and 3. So, paano ba malalaman? Paano pala kung magkaparehas silang carbon? So, we will base doon sa next na atom, which is O. Dito, oxygen. Dito ay hydrogen. So, mas matimbang ang oxygen kaysa hydrogen. Kaya itong COOH ang naging second highest priority. So, 1, 2, 3, 4. So, that's counterclockwise pa rin. So, S talaga ang ating configuration. So, that's S-alanin. Next, ayan. So, eto naman, identify daw natin kung saang following Fisher projections of glyceraldehyde represent the same enantiomer. So, kung saan daw ang parehas pa rin dito sa R-glyceraldehyde. So, let's have letter A. So, dito sa letter A ay pinagpalit lang itong dalawa. So, tama siya. Dito sa letter B naman. So, sa letter B naman, ayan, i-base natin siya ngayon dito sa letter A. Ayan. So, ngayon, ito, naka-hold lang yung H, tama? Naka-hold lang yung H, tapos ni-rotate niya lang ng clockwise. So, tama. On this one naman, hinold niya ang CHO at inikot niya ng counterclockwise. Kaya yung H ay nandito sa taas. Ayan o. From here, napunta dito. So, ito ay tama. How about naman dito? Ayan. May hinold ba siya? Diba? O, CH2, napunta dito. Ang H, napunta dito. Ang OH, napunta naman dito. At saka, ang CHO, napunta dito. So, wala siyang hinold. Nag-rotate lang siya ng 90 degrees at yun ay hindi allowed sa motions. Yun ay hindi allowed sa Fisher projections. So, ang enantiomers lang na nandito sa Fisher projections ng glyceraldehyde ay ang A, B, and C. So, eto naman, we have this example na pinagsabay na yung kung paano isulat ang Fisher projection at mag-a-assign ng R or S configuration to the chirality centers. Okay? So, we have this molecule. So, ang green daw ay chlorine and the black ones, this one, the black ones ay carbon, the white ones are hydrogen atoms, and this red one is the oxygen. So when we draw a Fisher projection from a molecular formula, we make sure that pag nag-rotate tayo, ang CHO, ayan, ang carbonyl group, or ang CH2OH, nasa tamang place. Ang CHO ay nasa taas, ang CH2OH ay nasa baba. So, anong gagawin natin? We will rotate it 90 degrees para ito ay nasa ilalim. Ayan, ganyan siya. Ayan. So, Fisher projections. Ilang carbon atoms? Ito, 1, 2, 3. So, isa lang ang chirality center niya. Kaya, ganito lang siya. So, CH3. So, this one, ang chlorine natin has longer line. So, dapat dito siya sa right. And H and CH2OH. So, that's the Fisher projection of the molecule. Okay. So, paano naman tayo mag-assign ngayon ng R or S configuration from that molecule? So, from mag-assign ng R or S configuration in that Fisher projection. Okay. So, sabi, kailangan na ang H, 'di ba? Kailangan na ang H ay nasa taas, mapunta siya dito. At kailangan lang natin mag-move by 180 degrees or by 90 degrees pero naka-hold ang isang group. So, we can hold the chlorine. Ayan. We can hold the chlorine. At then, i-rotate natin ito clockwise para yung H ay mapunta sa taas. So, CH3 nandito at H2OH. So, mag-assign na tayo ng highest priority. Mag-identify na tayo ng ating highest ranking to lowest ranking na substituent. So, ang 1 natin is chlorine. Diba? Ito yung 1 kasi siya yung may mas mataas na atomic number. Ang 2 natin is this one kasi ilang hydrogen yun. Ito 3, ito ay 2. And ito ay number 3 at automatic na ang H ay number 4. So, saan papunta? So, that's clockwise. So, pag clockwise, ibig sabihin siya ay merong R configuration. So, ito naman sa isa is we hold the CH2OH and we rotate these 3 clockwise para ang H ay mapunta dito sa taas. So, yan yung nangyari. Dito na yung H. Ang Cl ay nandito na sa left and nandito na yung CH3. So, now we will rank this remaining 3 groups from highest priority to lowest priority according to the number of to their atomic numbers. So first we have 1 sa Cl, 2 sa CH3 at 3 sa CH2OH. So pa-clockwise pa din siya. So meron pa rin siyang R configuration. So we are sure na meron talaga siyang R enantiomer kasi nakadalawang try na tayo. Okay. So let's have another example. Redraw the following aldotetros as a Fisher projection and assign R or S configuration to each chirality center. Kung kanina, isa lang ang chirality center natin. This one. Yan. Dito naman, madami na tayong carbons. So, meron na tayong ilang chirality center. So, first, diba, kailangan muna natin i-identify ang CHO. Ayan, CHO. At CH2OH. Okay. So, ito yung CHO, ito yung nasa taas, at ito ang CH2OH, at ito yung nasa baba. So, i-rotate lang natin siya ng medyo 90 degrees, i-upright lang natin para malaman natin ang Fisher projection niya. So, there. So, ito na yung CHO, not COH. Yan, CHO. Ayan. And then, this one, ang ating CH2OH. So, meron tayong na dalawang carbon na natira. So, that makes 2 chirality centers. Ayan. So, first, we have this first chirality center. So, ang red, ang kanyang oxygen has a longer line kaysa dito sa hydrogen natin ng isa, kaya dito siya sa left. On our third carbon, our second chirality center, ang Oxygen niya still has a longer line kesa doon sa ating hydrogen. Kaya dito siya sa ating right side. Okay. So now we will determine the chirality, the configuration of the two chirality centers. So first is the first chirality center, which is the carbon number 2. Kasi we have this 1, 2, 3, and 4. Ayan. Okay. So this one, our first chirality center. So, ang substituents niya ay this one, and this one. So, ang first natin, syempre, oxygen. Ang second natin is this one. Kasi, ilang hydrogen? Dalawa. Ito, isa lang. And this is 3. So, that's clockwise. That makes it 2R. Okay? Dito naman, sa third carbon, our second chirality center. So, same lang din as our first chirality center. So, that makes 3R. So, ang full name ng ating molecule is 2R, 3R, aldotetros. So, ganon magpangalan pag marami ng chirality center para malaman natin kung saan natin ipi-place yung OH natin. Ganon. Also, another way of identifying the carbohydrates is yung D, kung sila ba ay D or L sugars. So, pero siguro naman may na-encounter na kayong compounds merong D or L at the beginning of their names, 'di ba? Meron tayong D-mannose, L-glucose, 'di ba? May mga ganon. So, D stands for dextrorotary and L stands for levorotary. So, paano ba natin malalaman kung siya ay merong D or L? Okay? So, first, let's have an example. The R-glyceraldehyde. O, yan. So, ang R-glyceraldehyde, di ba, kaya naging R kasi meron siyang, ang highest priority niya is papuntang lowest priority ay clockwise. So, ngayon, malalaman natin siya na siya ay D-glyceraldehyde kung ang OH niya ay nasa kanan. Ganun lang siya kasimple. Kung marami naman, ito kasi tatlo lang siya, isa lang naman ang chirality center niya. Pag madami namang chirality center, i-base natin yung D or L configuration doon sa pinaka-last na chirality center. Ayan, dito lang sa last. Ganun lang siya. So, ito ay D-ribose, D-glucose, D-fructose. Pero kung ang OH nito ay nasa kabila at itong H na isa kabila, so that's L-fructose. So, ganun lang siya kasimple. So, let's have an example. Ay, meron pa palang meron pa palang example. So, we have L-glyceraldehyde or S-glyceraldehyde kasi 'di ba ang S yung highest priority niya to lowest priority is counterclockwise. So, itong L-glyceraldehyde man, it means that ang OH group niya on the last chirality center, ito naman isa lang naman, is on the left. So, on this one, we have L-glucose kasi nasa left ang OH niya. On this one naman, we have D-glucose. So, ang ating mga sugars, they occur naturally in their dextrorotary nature. So, walang sugar na walang naturally occurring sugar na merong L configuration. Okay. Ayan. So, let's have your worksheets number 2. Worksheet number 2. Ayan. Assign or S configuration to each chirality center in the following monosaccharides and tell whether each is a D sugar or an L sugar. So, madali na lang yan. Kung ano yung ginawa natin nung una, yun yung gagawin natin dito sa ating worksheet number 2. So, let's proceed to our next lesson. Meron pa pala. This one is also your worksheet number 2. So, yan. ang arabinose, ngayon naman, idodraw nyo yung Fisher projection niya. So, with this feature or characteristic or ang tawag nito, definition, description, yan. With this description. So, 2S, RS, 4S, tetrahydroxypentanol. Ayan. So, ganun siya. Okay. So, the configurations of the aldoses. So, we have different aldoses and nagkakaiba lang sila sa number of carbons that they have. Okay? Ay, gumalaw. So, number of carbons that they have. Okay, so first we have the aldotetroses. So, tetro kasi 'di ba, 4 yung kanyang carbons. And they are aldehydes. Ayan. They are aldehydes. So, they are aldotetroses. So, we only have 2 aldotetroses. So, that's D-erythrose and D-threose. Ayan. So, after that, pag nag-add tayo ng isa pang chirality center. So, kanina 2 lang. Ngayon ay 3 na. 1, 2, at 3. So, meron tayong aldopentoses. So, 5 carbons. So, yan ay D-ribose, D-arabinose, D-xylose, and D-lysose. So, we have a mnemonic device for that para mas matandaan natin. Ribs are extra lean. Yung ribs ribose, R arabinose, yung X doon sa extra is xylose, the L on lean is the lysose. Also, I also made this mnemonic device para naman malaman natin kung saan merong OH na napunta sa left. Okay? As we can see, okay, meron daw 0 sa R, yan, sa ribs, 1 dito sa arabinose, and 2 sa xylose, and 1 and 2 sa ating lysose. So, that means, dito sa ating ribose, walang OH na papadpad dito sa left. Okay? On arabinose naman, on the first chirality center, on the first chirality center, meron daw OH. So, yan. Sa xylose naman, on the second chirality center, meron daw OH. So, dito sa lysose naman, meron tayong OH sa left side ng first at second chirality center. So, ito yon. So, that's how I figured out na meron pala, pwede siyang gawin na may mnemonic device. So, after aldopentoses, if we add one more chirality center, we will have aldohexoses. So, hexoses, so meaning meron tayong 6 carbon atoms in our sugar. And aldo, yun pa rin, merong aldehyde group. So, merong mnemonic device para masaulo natin yung lahat ng aldohexoses. So, all altruists gladly make gums in gallon tanks. So, allose, altrose, glucose, mannose, glucose, idose, galactose, and talose. So, I also have here a mnemonic device I made na kung saang OH ang nalipat sa left. So, sa allose natin, yan, dito, sa first one, sa allose natin is 0. So, walang OH na nalipat. Okay? Second ay 1 para sa altrose natin. So, ibig sabihin, on the first chirality center, merong OH na nasa left. Ayan siya. And other one, 2, para sa ating glucose, ibig sabihin, ang OH niya ay nasa second chirality center, na nasa left. Ayan. ang 1 and 2 para sa ating mannose. So, sa first and second chirality center, ang merong OH na nasa left. Sa ating namang glucose, we have 3. Ibig sabihin, ang OH niya ay nasa left. And sa ating idose, we have 1 and 3, meaning we have OH sa first and on the third chirality centers. And this one sa ating galactose, we have 2 and 3, meaning on the second and third chirality centers, our OH group is on the left. Ayan. And 1, 2, 3 para sa ating talose. Ayan siya. Talose. So, on the first, second, and third chirality centers, merong OH. Ang OH natin ay nasa left. Ayan. So, that's the configurations of our aldoses. So, how can we know how many stereoisomers does a sugar have? Okay, so yan. So, we have this formula. Ayan. So, small n stands for the number of chirality centers, and this capital N is the number of possible stereoisomers. Ayan. So, let's have an example. This D-erythrose. Ayan. So, ang D-erythrose has 2 chirality centers. So, 2, ayan, yan. So, 2 times 2 is 4. So, we have 4 possible stereoisomeric aldotetrosis. So, ito yun sila. So, una is yung given na structure. So, that's, ano na talaga, yun ang unang stereoisomer. Ang second ay this one. So, on this one, parang nilipat lang yung OH dito sa left. Okay. On the third one naman, ang nilipat lang na OH ay doon sa first chirality center. Nilipat yung OH sa left. On the third one ay nilipat ang OH ng second chirality center papunta dito sa left. So, that's how you draw the stereoisomers of a sugar. Parang baliktad lang, one by one. So, pag ito naman is like, yan, so CH2, ayan, tapos dito ay CHO, I mean. Tapos ito ay OH. Ayan. So, pwedeng itong dalawa dito sa kabila. Tapos, itong dalawa naman, dito na ulit sa kabila ulit. Parang ganun lang. Ganun ang mag-write ng stereoisomers. Okay. Ayan. So, that's how. So, worksheet number 3. Draw the stereoisomers of 2 aldopentoses of your choice and 3 aldohexoses of your choice. So, yun pa rin yung magiging formula ninyo. And then, bahala kayo kung anong aldopentose ang gusto nyo. 2 doon at 3 aldohexose. Basta, ma-write ninyo yung mga stereoisomers nila. Now, aldehydes and ketones undergo a rapid and reversible nucleophilic addition reaction with alcohols to form hemiacetals. Hemiacetals are a functional group having one oxygen that is bonded to a functional group and one oxygen is bonded to an OH, bonded to a hydrogen that they are bonded to the same carbon. So, the OR group and the OH group are bonded to the same carbon, just like this. So, etong R na to, pwedeng CH3, pwedeng COOH, ayan. So, yan yung mga side chains na tinatawag. Okay. So, let's have an example. So, the alpha D-glucose. Ayan siya. So, yung alpha D-glucose. So, glucose na lang muna. So, ang glucose natin, ito ay dati ay may OH to. At ito dati is CH2OH. Ayan siya dati. Wala pa ito. Wala pa yan. So, ito lang dati is CH2OH. Ayan. So, ngayon, yung first doon sa glucose natin, di ba ang glucose is all, altruist, gladly. Ayan. Pangatlo siya. So, ibig sabihin is 0, 1, 2. On the second chirality center, yung OH niya ay nasa left. So, ito yun. So, this one is the first. So, dati ito is CHO. Ayan siya. Ganyan ang glucose. Okay. Now, yung carbon doon sa CHO ay nag-bond dito sa oxygen ng 5th carbon on our last chirality center. So, ngayon, nung nag-bond siya, yung H dito ay napunta dito sa hydrogen sa taas. Doon, nag-bond siya doon sa oxygen ng first carbon. Okay? So, ngayon, naging ganito na siya. Naging Hemsworth. Hemsworth. I forgot. Hemsworth ata. Hemsworth na model. Ayan siya. So, ito yung oxygen ng 5. Okay? So, ito yan. Ito na yung first carbon. Ito na yung second carbon, third, fourth, fifth, and sixth carbon. So, yan yun ang pagbilang. So, yung fifth carbon, ito na yung kanyang oxygen. Okay? 1, 2, 3, 4, 5, and 6. Okay. So, alpha. Ibig sabihin ng alpha, ang OH na nagawa ay nasa right. Okay? So, kaya, ang OH niya ay pababa. Laging tandaan, when you are right, you are humble. When you are humble, ikaw ay mapagkumbaba. So, lagi kang nasa baba. Okay. Now, so when you are arrogant, diba? Pag arrogant ka, gusto mo laging nasa taas ka. So, ikaw ay mapagmataas. Okay? So, on the first carbon, alpha daw. So, yan, nasa right. On the second, nasa right ulit. So, mapagkumaba siya. On the third one, siya ay left. He is arrogant. So, nasa taas siya. On the fourth ay nasa baba kasi nasa right. And yung 6 lang natin ay nasa taas. CH2OH as is siya. So, ngayon, from this model, Hemsworth, you can siguro i-google nyo na lang kung Hemsworth na talaga. Hindi ko ma-sure. Okay. From this Hemsworth, gagawin naman natin siyang in a pyranose form or pyranose form. Pyranose. Pyranose form. Okay? So, ngayon, yung O, nilagay lang natin dito. Okay? Tapos, yung fifth carbon, parang binaba lang natin. Ayan. Parang nag-chair lang siya. Ganyan siya. Okay? So, this is your first carbon, second, third, fourth, fifth carbon, and ito yung sixth carbon mo. But you can write, yung pag dito na, you can write na lang ay CH2OH na lang. Pwede ding ganon. Okay? So, sa first carbon, pababa, yung 3, paslant, pataas, kasi diba nasa left nga siya, and this one ay paslant, pababa, yung sa fourth carbon, yung OH niya, kasi nasa right. So, ganon lang siya kadali. So, beta, kung kanina alpha D-glucose, ito naman beta D-glucose. Ibig sabihin ng beta, ang OH group na nagawa ay nasa left. Kaya siya ay beta. So, pag beta, ayan. So, first, ito, 1, 2, 3, 4, 5, 6. On the first carbon, ang OH niya ay nasa left. So, siya ay mapagmataas. So, kung paano natin ginawa yung sa una, ganun lang din dito. Yung mga OH lang yung babaguhin natin ng placement. Okay? So, yun dito din, pataas din yung dito sa kanyang pyranose form. Okay? So, let's have, ito, wag na siguro to. So, let's have an example. So, D-mannose differs from D-glucose in its stereochemistry at C2. Draw D-mannose in its chair-like pyranose form. Okay. Ang D-mannose is, ano ba yung mannose? Aldohexose din siya. All altruists gladly make, yan, sa make siya. So, ayan siya. Ayan siya. Ito yung ating mannose. Ayan. So, 1, 2, 3, 4, 5, 6. Ang sa mannose ay 0, 1, 2, 1, and 2. So, ibig sabihin, on the first and second chirality center, meron siyang, on the first and second chirality center, meron siyang OH na nasa left. So, ito yung first chirality center. Ito yung second chirality center. Nasa second carbon at saka third carbon. So, ito yung OH niya. Okay. Now, yung carbon daw ng first, yung first carbon daw is magbaband doon sa O ng hydrogen, O ng fifth carbon, sa oxygen ng fifth carbon. At yung H na to ay lilipat dito sa oxygen ng first carbon at magiging ganito. Ganyan siya. Ayan. So, ayan siya. 1, 2, 3, 4, 5, and 6 carbons. So, from here, okay, from this structure, gagawin na natin siyang Hemsworth structure. Ayan, this one. So, yun. 1, 2, 3, 4, 5, 6. So, yan. Ang first carbon natin is, ang OH ay O. Ang OH ay nasa right, so, nasa baba. Sa second and third ay sa left, so, nasa taas sila. This one. And yung sa fourth carbon, ang OH niya ay nasa right, so nasa baba siya. And fifth ay wala ng OH kasi 'di ba napunta na yung H niya dito. Ayan. So ang 6 ay as is lang na C6 CH2OH. So from this form sa ating from this form ay ginawa na natin siyang pyranose form. Pyranose form. Ayan siya. Naging pyranose form na siya. Ganyan lang siya. So, this one is alpha because ang nagawa niyang OH on the first carbon ay nasa baba. Okay. So, that's how you draw the Fisher projection to a Hemsworth model to a pyranose form. Okay. So, paano naman ngayon kung siya ay 5 lang? 5 lang yung carbons niya. Like the D-ribose. Okay? So, ang D-ribose exists largely in a furanose form. So, kailangan daw natin i-draw ang D-ribose in the furanose form. Okay? So, ganyan lang siya. Okay. So, ang, diba, ang ribose ay sa ribs. Ribs are extra lean. So, the ribs, so, 0. Wala siyang OH na nasa left. So, ito lang siya. Ayan, ito yung ating, D-ribose. Okay. So, ang first carbon ay mag-a-attach daw doon sa OH or sa oxygen ng ating fourth carbon. At ang H ng fourth carbon ay mag-a-attach dito sa ating first oxygen. And we will have this one. Ayan siya. So, ngayon, meron na yan dyan. ganito lang mag-draw ng furanose. Para lang siyang bahay. So, ito yung oxygen na punta dito. Yung first, dito na, first, ang tawag nito, first carbon, second, third, fourth, and the fifth. Ayan na siya. So, first carbon natin, ang OH daw ay nasa right. So, ang OH ay nasa baba. And this one also sa baba, sa baba. Okay. This one ay wala ng OH kasi 'di ba ang H niya ay binigay niya doon sa oxygen ng first carbon. So, yun lang. Ganun lang kasimple. Now, on your worksheet number 4, draw the different representation of the structure of beta L aldose, alpha D glucose, and beta D tallose. So, isusulat nyo dyan from their Fisher projection to Hemsworth model to pyranose form. So, sundan nyo lang yung ginawa natin kanina. Sundan nyo lang to kung paano ko yan mong ginawa. Ayan. At malalaman nyo na ang sagot dito sa ating worksheet number 4.